Hello, my name is Logan Mendizable, and I am going to be applying my knowledge of the kinematics of a particle to a real-world problem. What real-world problem, you ask? Well, how far a car goes after a certain amount of time. As you can see from the picture on the left, the car is going 30 miles per hour. How do I know this? Most neighborhoods without a school zone have a speed limit of 30 miles per hour. So, assuming that the car shown isn't speeding, it's driving at the speed limit. What I want to find out is how far a car goes before it has to stop at the stoplight after 7 seconds. I use the timer on my phone to get the time it takes to get from the crosswalk to the stoplight via car. There are two kinds of final assumption I made here. One, that the car being treated here like a particle, and two, that the deceleration is constant. Why assume that second point? Because you generally gently apply the brakes when slowing down while driving instead of randomly slamming the brakes down to completely stop. As you can see from my diagram on the right, the car is heading in a straight line to the right, which we'll define as positive. We'll also put the origin at the crosswalk for convenience, so the initial distance is 0 miles. Once the car fully stops, the velocity is at 0 at time 7 seconds, which converts to 0.002 hours. That just leaves with the two unknowns, the final distance, which we're trying to solve for, and the deceleration. In order to solve this problem, I need to apply some key concepts. First off, rectilinear kinematics in terms of continuous motion, since the car is traveling along a straight line. Then I need to apply the concept of velocity and position as functions of time in order to solve for position, since velocity and time are given. The equations needed are the constant acceleration equations for velocity and position. We need the velocity function to solve for the constant deceleration, since the final and initial velocities are given as well as the time. Then we need the position function to solve for the final distance, which would give us the answer to this problem. Well, that's as far as I can go, so bye.